Hi folks, we are back once again with the next problem number 20 of this voluminous exercise 6.5. We are moving to more and more core level problems in this exercise. The next problem we will be talking about the cylinder. Now you always have to keep one thing in mind, that as I had told you earlier, there will be a data that is given to you which will help you to find the value of what they ask, so what is given, that has to be traced properly, and what has to be found out, there we will have more variables, so the variables have to be reduced to one variable, and then your work of first derivative, second derivative, critical point has to move. So always remember that 2 or 3 variables. For example, volume of a cylinder will have pi r squared h, so r and h, these are 2 variables that has to be replaced, and you have to replace it and make it into one variable, only then you're able to get the derivative and so on. So that strategy we are going to adopt over here, and we are going to do our work. So always keep in mind, our idea is to reduce to one variable and then do our work. So as to get one variable, there will be some data given to you that you have to use properly and get it reduced to one variable. Just quickly see what the question number 20 says. It says that show that the right circular cylinder of a given surface. Now this word you have to catch. Given surface means in fact it means that surface area is given. So given means it's constant, it will not move, it will not change. So that you have to use in order to replace maybe the variables, 2 variables, making it one, etc., of a given surface and maximum volume. So you have to find that the volume is maximum, is such that the height is equal to the diameter. Now that is actually a proof that question, that whenever you get a maximum volume, height will become equal to the diameter, that you have to show. But that is a secondary, that we will maybe get it later as we solve the problem. So as we said, now we are talking about a cylinder. Suppose say we are talking about a cylinder like this. We all know that cylinder has got 2 parameters. If you have to know the cylinder's formula fully, you have the height and you have the radius. So let h comma r be the height and radius of the given cylinder. And maybe you can say S for, or A for area, that's one's wish, and S comma A, S comma B be the surface area, and be its surface area and volume. Okay, it's given to us, given that the surface area is given to us, and surface area we all know is going to be 2 pi r squared plus 2 pi rh. See, we all know that the volume is pi r squared h. So it's the volume which we have to work on, because it's been told that the volume is maximum. But when we look at it, we know that r and h, they are 2 variables which we cannot work with. So in order to make it one variable, it's better that we replace r squared or h. That's your wish. You can replace any one. R squared, because it is a quadratic, the replacement will call for a lot of work. So we would prefer to substitute h. So with that point of view, let's try to get the substitution for h. So I will just once again check if they give us anything about the surface. No, it's a given surface. Yeah, sometimes they give you that surface area is 100, 20, 30, whatever. So that will be more useful. But here we'll keep it as s. Then in that case, what happens to our value? We want to replace the h. So in the first step, 2 pi rh is s minus 2 pi r squared. Since we want h, let's shift this. S minus 2 pi r squared over 2 pi r is your h. That means wherever required, this is going to be your substitution. Let's quickly switch over to volume. Why we did this? Because we wanted a substitution. Earlier cases were very simple, where we had the sum x plus y equal to 24. We used to put y equal to 24 minus x. It was only that much. But here it's not like that. It's a complicated thing. So you have to first get the replacement and then talk of volume. We know that they have asked us the volume. So let's talk about the volume now. The volume we know for a cylinder, it's going to be pi r squared h, and we know that we have to work with dV by dr or dv by dh and its second derivative also. We have planned to replace the h. So let's get it in terms of h now, in terms of r now. So pi r squared, h is getting replaced. It is becoming s minus 2 pi r squared over 2 pi r. We have replaced the, why we got it? We got it from 1 because we wanted to replace it and make it one variable. See what simplification is possible. Pi can get cut, r can get cut. So you're left with that 1r. Let's open the bracket. It's very difficult to keep it like this. So it's going to be maybe half times, say, SR minus 2 pi r cube. Half also you can take it inside or let it be there. It will not make much difference. So that's our volume V. Our first task is to get dV over dr. So how much is that? Half times derivative with respect to r, this will be s, and this is 2 pi. R cube is going to be 3r squared. That's our first derivative. Quickly, we will find the second derivative also. dv squared by dr squared is half times. S is a constant now, so it will not contribute much. So let's have this 3 2s are 6. So minus 6 pi r squared will make it 2r. So this is going to be the 2 can cut here. So you have minus 6 pi r. It's going to be negative. That's how it's maximum. So why? Because r is always going to be a number, radius, and then with that negative sign there. Okay, that's secondary. Now let's go for the critical point. Let dv over dr be equal to 0. So what happens? It is like it's half times s minus 6 pi r squared equal to 0. I've just simplified it. So we can take the 2 on the half. The 2 is in the denominator, it can go on the other side, so that way it will get eliminated, and so you get 6s minus 6 pi r squared equal to 0, s equal to 6 pi r squared. Now this is what we are going to use actually, but technically you should know the value of r, but if you take the value of r and go to substitute and work out, it's going to be laborious. So that is why you can work with this. That is the winning part of this problem. Generally, technically, correctly, what we are supposed to do is you should get the value of r. So what is the value of r? R square is s over 6 pi. So r is going to be root of s over 6 pi. Now that's very complicated to work. So in order for all our further calculations, we should use this. That's easier. So I'll tell you how. What all things do we need to do now? We are almost through. We have got the critical point. We have to check that at the second derivative, this will give a maximum. That's our first thing to check. And second thing to check is that they have told us that height equal to the diameter. So these two things is left to check. So let's do that checking. So what we are going to do first is to ensure that it's a maxima point. So therefore, d squared v over dr squared, I'm checking when s is 6 pi r squared. It's the same. Or you check at this. Both ways it's correct. So what will happen? We are left with, okay. So I think it's better we substitute this value itself because they tell that it is, yeah, it's r equal to s over 6 pi, root s over 6 pi. Okay. So what is it? Minus 6 pi r. So root s over root 6 pi, whatever it is, that is going to be a positive value. So overall value negative. So therefore, r equal to root of s over 6 pi is a maxima point or maxima occurs. Therefore, maxima occurs. Okay, that's not all. They ask us to also find out that h is equal to d. So for that, let's take 1 from 1. Let's call this as 2. From 1 and 2. Yeah, we are not reluctant. We don't want to use r as root of s over 6 pi. It's like very complicated. So instead of that, it's the same. They are the same. So we are using 1 and 2. In 1, they say that h is equal to s minus 2 pi r squared over 2 pi r. Now we know that s is 6 pi r squared. So let's substitute 6 pi r squared minus 2 pi r squared over 2 pi r. So that makes it 4 pi r squared over 2 pi r. That will Pi cancel twice, r can cancel 2r, and we know that 2r is always d. So therefore h equal to d. Hence proved. Now they have said that show that the height is equal to the diameter and all that. So therefore, that's how we are able to show this. Uh, that's how we are going to have the next 2 3 problems is going to be of that kind, where they talk in the next problem they give us a volume and they ask us to find a certain thing about the surface area. Here they gave us a surface area, they asked us to find a certain thing about the volume. This is simpler. The next part is going to be a bit more of work. So that's all about this question. With the next question, which is like this, just the other way around, just the converse. With that problem, we meet in the next video. Thank you.